Okay, I hope we are okay. Now let us turn to multiplication. Multi-what? Now, during multiplication, especially for negative numbers, multiplication. So, in multiplication, we separate the mantissa from the characteristic. That very, very correct. Yes. Now that is true if the number is negative. If the log number is the entirely positive, you just multiply direct. So work out the following given logarithms. Given what? Logarithm. That's 2 into 1.4671. Then you have a scenario like this, negative 2.4410. Now look here. When it is a positive, multiply direct. So you'll have 2 times 1.4671. That will give you an answer there. Maintain it for decimal what? But when it's a negative, we separate the mantissa from the characteristic. So it's negative 2 plus 0.4410. Multiply this 3 times negative 2 plus 3 times 0.4410. So you'll get negative 6 plus what? Somebody with a calculator here. 1.323. 0, not so? Now add. This is added to that. We don't add the whole thing with the calculator. We add these parts alone. So it's negative 5, then maintain this 0.3230. So I'll only give one example. We shall meet many others as we move on. So that's exactly. Now let us go to division. During division, the same rules apply. When the number is a what? Is a positive, divide direct. When it's a negative, you separate. So the following. Now we are looking at what? At what? Division here. Following logarithms, work out. So 3, now like 2.1441 divided by what? By 3. Then we have a scenario where I have negative 3.214 divided by 2. Now look at division here. If it's a positive divide, maintain to 4 decimal what? Places. Somebody, I've got the answer, 0.7134. Then somebody here with 7137. Okay. Now look here. If it's a negative, you separate. So we separate. Let me start with the 4 here. I start with the 4. Then I'll go on. So now we separate into a term that is divisible by what? By 4. So we create a 4 up. Oh, this 3 is made into a negative 4. So I'll have negative 4 plus what? Now what do I add to negative 4 to get? What do I add to negative 4 to get to get what?
-1. You add 1.
I add 1.
Yes.
This one gives me this. So I maintain 2, 1, 4, not so?
Yes.
Out of 4, out of 4. So this will give us -1 plus what? Divide. This one that I had put is this, out of what? To this part, see?
0.3035.
0.35. So you join them, this with that, so you'll have -303 what? 5. See? Now look here. This part must remain positive. See? And you create a term divided by what? By 4. Therefore, what will this be? What can this be?
6.
6. What's the nearest divisible number? That's 4. That one will be -3 plus 4. Which the negative must be separate. So 2, 4, 1, that out of 2. Because 4 plus this gives, are you sure? Does if, wait, this is being confused and running berserk. Not so? So, if we separated here,
-3.
-3 minus 1. We need the other part to remain positive.
Teacher, we can use 2.
We can use 2 itself. No, if we use the 2, if the term to add to this to maintain, if you use the 2, what do you add to 2 to get -3?
It will have to be
a bigger negative value.
We can use 4.
If I use the 4, which value do I add to 4 to get?
So that 4 must be negative. That 4 being negative.
Negative, yes. Plus what?
Plus 1.
These girls can think beyond me. I've seen. Me had been defeated. My head had ended. You see? That's now what?
Negative.
A 0 point what?
607.
607. That gives us this. Not so?
Yes.
Wonderful. You deserve 10 billion hand claps. So.
Isn't it?
You even doubt yourself
No,
again.
I'm not doubting. It is 0.06.
It is 0.6.
607.
0.6071, like that. That's like this. So wonderful. Okay, capture that. We start on now actual work. We've been in practice. Did you hear that statement?
Yes.
We've been in. Yeah. You see. Let me pick numbers here. Now we are getting a general question called use logarithm tables. Use logarithm tables to evaluate each. To evaluate each. So each. Prepare to handle some, not so. That very clear to your head. 0.224 times 44.1 out 44.1. We start with that. Of course, you can even get the answer and keep it with your calculator and find out whether the answer you get will be the same. Now, this is what we do. We should build the concept in the head that if we are to take the log, if we are to say log of multiplied numbers, it implies the logarithm values must be what? Added. Let us explain that. Since they said use logs, we introduce what? We say logs of that. Not so. What does multiplication mean? That it means that they were being added. So that's the, if this was being added to that means we are multiplying them. So it means that when we are seeing a multiplication, we are going to be adding our log answers. If there is a division, we shall be what? So now let us start on. Okay, we introduce our normal table. Number, standard what? Then logs. See. Okay, the first number is 0.224. What is it here? 2.24 times 10 to the power what? -1. Therefore it falls here. Get us to 4DP. Either use the logbook or use this. 3502. Go to the next one. 4 point what? That is 4.41 times 10 to the power 1. Okay, it becomes, press the log of this. 64.35. Okay, now because of multiplication, we what? Add. We add 2 plus 5, 0 plus 3, 5 plus 4, 3 plus 6, -1 plus 1, 0. Then at that stage we carry out what we call a what? Ant log. That means we are turning it to the number, and this simply means 10 to power the value, not so? 10 to power. But since it does not have the characteristic side or the integer part, we just put on the calculator. You can say ant log or direct there. 9.856 is to 3DP. 9.856 exactly. Okay, so 0.224 times 4.1 approximates 9.5856. Could you test? Is it correct? If you test by a calculator and you multiply and round off to 3,
yes,
it gives that. Yeah? Okay. I'm bringing you to it gives what?
9.878.
9.878. It means you've given me one thing that's incorrect. Check. Log of 2.24.
The log of 4.41
is wrong. What is it?
My it is 64.
It is what?
6444.
Like this?
Yes.
Yeah, you see? Okay, this plus that is 6. This plus that is 4. This plus that 9. Okay, and log of that Then you were about to say, to choose the method.
9.876.
Which is the same. Okay, we move on, not so. Yeah. See, I'm changing to another number. Part B, I'm giving a quite big 1.78, 0.00641 out of 0074. Okay, number standard what? I want you to be very, very attentive here. What do we write here? 4.78. 4.78 to power 0. 0 point. Now look, here there is multiplication and finally you divide. So we shall get this answer added and sub 6794. So get now next 0.00641, that is 6.41 times 10 to power negative 3. So it gives us that. That will be
0.807.
Read for us just those digits.
0.807.
Zeros. Just read for us the other digits after decimal. 8007.
Mine gives 0.8069.
8061. Maybe our calculator got it.
It is 2. There is it.
It is 2 on round. Make sure if you're using a calculator, you are to a risk. If you forget to round off, you are gone. See, you are gone.
Teacher, the book says 9. It's 9 there, teacher.
It's even the calculator says the same. It's a calculator which spoke wrong things, not so. Let it speak to you correctly. You convince it to talk to you well. The calculator. You are not convincing it properly. So we add, not so? First work on this before bringing it. So there you are. So this plus that. 13. So carry 1. 16 carry 1. 8. 14.
Negative
1 plus negative 3. Negative 2. Negative 2. Now bring in now the denominator. So if I close this, that is what? That is 0.074. That is 7.4 times 10 to power what? Negative 3. So negative 3 point. 8692. So we subtract.
Yes.
3 minus that.
1.
6 minus that. Impossible. We carry. That's 7. That's 16 minus 9.
5.
We get 16 minus 9. 7. 7 minus 6.
1.
That's exactly. 4 minus 8. We borrow. Negative 2. Remove 1. Here we are remaining with what? So this is 14 minus 8. 6. Not so. Negative 3 minus minus. Negative 3 minus minus. See. Then you anti-hot. Anti-log. What? That said we just say 10 to power. What do you get here?
4.140.
1?
No. 4.140.
4.14. Yeah.
But it will have to be 1 because the next number is.
Ruth wants it to refuse.
And now, teacher, not about the answer. Sorry for going back behind. But when we had started these things of addition,
when we had started them,
you said that no using a calculator. But
did I say so?
Okay.
Yes. Are you using a calculator here? This is why I meant don't use here what? Because assuming you put negative 2.48, this is minus negative, you are going to get a wrong answer here.
Okay.
So, doing this other one, now there is deep life here. Deep life here. See? Now this one needs real attention. So I'm modifying it here. Square root of 0.477 times 2.4 out of, now we are widening it to be so big, so hot, so hot. Yeah, now look here. This one means it has a power of what? A half. So, power of a half means what? If we have a log of 2 to power a half, it means a fractional power means you will divide, because you will have half there and it will become log of 2 out of. So we shall divide by 2. But if you have a square power, you'll have to multiply. So, now these are deeper things. Are they deep? Not too deep. Now, immediately I finish this class, I'll do more 2 or more 3. Then we request for people to come and close with these other numbers that will be following on this board here. Now look here. Let us start. Number, standard hot, form, then hot, log. Let us start right away. 0.477. 4.77 times 10 to power negative 1. So this becomes so. Log of this is 678.5. Now wait. At that stage, we are to first divide it by what? By 2. Look here now. Divide by 2. You'll do rough work from somewhere. That means you'll go on your side work and work out. Negative that, divide by that. You'll split this to be divisible by 2. So it will be negative 2, not so? What do I add to get this? What do I add this to get back this? So I'll divide it by that. Divide here, that's negative 1.0. 0 point what? Eight what? 8 3. 9 what? 3. So it becomes this, not so? 8 3 9 3. This is what you write here. 0 point, that's what? 1.8393. See? Then we bring this into play, not so? So 2.4 will become 2.4 times 10 to the power what? 0. What do you get? 3 what?
802.
0.302. So we do what on these ones? Now listen. Here we shall add, get the answer. Also here we add, get the answer. Then this answer and this answer we subtract. This is very, very interesting. Did you know that?
Excuse me, teacher.
Yes.
Why isn't it allowed to divide before logging?
You can. You'll be. It's like if how do you divide this? This does not mean so, because here you have applied log. You've applied log here that step. If you or else take square root of this, but it will give some errors in the, because if you take square root, you'll again have round off first, then come and work with it. But of course it will yield the results. But that's not what the intention of the examiner. The intention of the examiner is this way. So add for me. This
5,
this
9,
this
11,
this
12.
1 plus negative 1 plus 0.
0.
So keep that answer. Proceed now. Now we pick this. So 0.814. 8.14 times 10 power what?
Negative 1.
See? Therefore it becomes this
0.9106.
06. 0 what? 6. So 20 what? 2 point what? Times 10 power what? 1. Put it here. 3424. Then what? Add. Not so? Add. Now. Add now. 6 plus that, 10. 3. 5.
12.
1, not so?
Yes.
1 plus negative 1 is 0, plus 1 is 1, not so? Now, this one, 0.2195, and this one, 1.2530 are going to be what? Added.
Subtracted.
Oh, added.
Subtracted.
You see? See that? Now, you see that? 5 minus 0. 9 minus 3. 6. 2 minus 5. No, what am I doing? 1 minus 5. We borrow. 11 minus 5.
6.
1 minus 2. We borrow. 0 minus 1. Therefore, I have this, not so? So 11 minus 2.
9.
So, negative 1 minus 1.
Negative 2.
Then you do what? You antlog, or not so? Now, see? What does antlog mean?
10 to the power.
So, you could here say, you could just say 10. I hope you'll understand it to be this times 10 to power this. We saw this before?
Yes.
So get this to 3 decimal places first. Did you hear that statement?
Yes.
What do you get? First get this to 3 before you multiply. Because you'll be in line with the logbook. Oh, that is correct. So, what do you get?
.278.
You multiplied. What was it to 3 dp? 9.27 what? 8. This was what?
It was 9.260.
9.2?
No. Changing it to 3 to 3.
Yes, it is.
0.967.
No, this to power, this is what? 0.
9.268.
268. So, you now multiply by this. This is like 1/100, of course. You can command the calculate 0.001. If you multiply this, you land with what? That means my answer here, you just put in the calc this one, round off to 3 dp, multiply. Is that a query? What do you get here? It's like your complex, you know, so 1, 2, 1, 2, 0.09, 9. Now we are going to round the final answer to 4 decimal.
7.
To what?
7.
Is to 7. This is now to 4 decimal. Pensions, you seem to have been have the numbers interested you very much? The numbers have interested her very much. Now, in trying to summarize, we can have this. Find the square root of what? Find the cube root rather. The cube root of 0.0297 using logarithm tables. So this means cube root means this. 3 is there, not so? Which means to power what? A third. It means I'm going to divide number standard what? Logarithm. So this will be 0.0297. This is 2.97 times 10 to the power what? -3. Drop it here. Point. -2. Wonderful. You deserve to be appreciated daily, which is impossible. .47 2. Not so? 2. Now 4 decimal places. 7 like this.
No, it will be
8. Now we divide it by what? Now do it roughly somewhere. What will you split it, of course, into a divisible term of 3. This will be what? -3 plus what to get -2? Plus 1. So I'll get this as 0.728 out of 3. Yeah, what do you get here? -1. Here it is. Therefore, that's what you get. Ant log for us it, and we get our brute here. That is 10 to power -1.4909. So this will now be times 4909. Okay, what do you get here? First get this to 3 dp. The table gives this to 3. Then multiply. Patience, you have the answer. You doubt yourself.
0.0.
This one is 0.
Oh, the first one is
3.097.
3.097.
Then we are timing this. So it is 0.
Children, this 0.01.
No. Think left hand, right. Oh, that's right. 0.97. You test it. Is the cube root to this? Now I'm going to see. Somebody who doesn't not find the cube root, I'm going to see. By calculator. Who doesn't know how to get cube root? Grace, you are pressing 1 million times so far. You look for that button called this, star this. Then you first press 3, shift, I think you look for it on shift, because it's not on the button itself. So shift 3, then you press that, then you put in the value. Do you get this perfect? Yeah. Put the shift this, then fill in the answer. So now never work out most numbers in math. You must prove that you are correct or you are wrong. Now I'm still doing numbers. So yes,
But with that last answer there.
was wrong.
9.2 58.
Why did you give us a wrong answer?
They gave you 506.
It was 5.
It was 9.268. But that 6 was supposed to be a 5.
A 5. Oh, it is. But you'll correct that. There was supposed to be a 5 here. But you'll correct that. In the previous example, you'll correct that. So, now allow me to do this. That's all. We can call them miscellaneous. Have you ever heard of that word? Somebody, a student of English, could you look for us the meaning of that? Find x. 3 pi x is equal to 5. Now in the remainder, if you had 3 pi x is equal to 3, what would be x? 1. Because the bases are? But when the bases aren't the same, we use logarithms. You see? We introduce logarithms on both what? Introducing logarithms. Therefore, I will say log of this to power x is equal to log of what? So, we drop this side. Did you remember that? X log 3 is equal to log of what? So we divide both sides by log what? Log 3, log 5, log what? 3. So my x, you press on the calculator direct to 4 decimal places. Log 5 out of log 3, it will give you
1.020.
You get 1.20. 1.0203. Okay. Allow me to do more 2 numbers only. Is that very, very correct? I've allowed okay. I'm still on miscellanea. It's number 1. So number 2. Oh, that's right. So, that's right, exactly. Given log 10x is equal to 2.852, and log y 10y equal to negative 2.581. So evaluate x to power half out of y to 3 significant figures. Now I'll do that and also do this. Then you are warming up, not? Grace Mokisa. I hope you'll be the one getting the first Mokisa, not so? Because you are called that name. The first blessing. Are you ready, Mokisa? to get the first blessing?
Yes.
Yeah. I think we can capture that and start on that. Yeah. Let me also put this one as number 2, number 3. This was number 2. Express 150 as a product of its prime factors. That's part A. Part A. Then part B. Using the result in A, find log 150 given log 5 is 0.6900. Then log 2, log 2 is 0.3010, log 3, that is 0.4771. Could I start on this? They are my last numbers under logarithms. I hope it was a very, very long hot. See? Very, very long hot. Now, see? Now, look here. It did say that you are given logs, but you find a number without logs. That can't work. So, we are to introduce logs on this one first. Because these are logs, there is no way a non-log number can work with the logs. So, we introduce logs. So, now listen. When you introduce logs, you will have to remove the logs by a process called what? Anti-log. So, we shall say log of this, taking logs now, log 10 this. See that? Now, we split using the laws. What does division say? That they were being subtracted originally. So, you'll have the same base 10 x power half minus the same base 10. See? Not so? Drop this what? So, you'll have a half log 10x minus log 10 what? Y. But a half means you are dividing by what? By 2. So I'll get this log of x divided by what? Which is this 2.852 divided by 2, subtract negative 2.581. You agree? So what is this?
1.4.
Maintain the calculator to 3dp as it was. So you'll have it is what? 426. Now I'm subtracting. We say don't subtract using a calculator. So 6 minus 1, 2 minus that. Borrow, remove 1, 3, put here, 12 minus 8, see, borrow, 0, not so?
Yes.
13 minus 5, 8, 0 minus negative 2,
Positive 2.
positive 2. So you anti-log that thing because you introduced logs. So you say anti-log it. We said don't waste the time. Okay, that will be 10 to power what? This means 10 to power 2 times 10 to power 0.845. Get this to 3 decimal places first, then multiply by that. So you get what? Six point nine.
0.
No, what did this become? To 3.
It's
It is 6.99.
8. Yeah.
And now round off to 3 dp. Or read from a log or a book there. You can read from anti-log book 0.884. 0.845.
69.98.
6.998 like that.
Yes.
So multiply by 100, you'll get 699.8. So this answer is 699.8. So you'll say x to the power half out of y will equal to 699.8. Now permit me to do the last one. So permit me to do the last one. Okay, now look here. Express, who do help me on part A? Who do help me on part A? Express as product or prime factors, or you guide.
The first prime factor.
Wait, this one we are okay, not so? Now listen. Assuming they said, given this and this, evaluate log of this. No need to anti. You end where? But because it did not have a log, and we introduced log so that you can speak of logs, the values given are for logs, therefore you have to introduce what? So, yeah. Now, let me take you here. Let's break this part A. It would be 150 by factor 3. That would be by 2. Run. 75 by 3. 25 by 5 by 5. So 150 is what?
2 times 3.
There you are. 2 times 3 times 5 to power what?
2.
Now that is your part. And now it is saying in part B here, see, look here, that log, now you find, use your things to find log 1 what? So I will say my log 150 now becomes similar to log of what? This 2 times 3 times 5 squared. Now what does it mean in logs when there is multiplication? So that's wonderful, fantastic, fabulous, wondrous, bombastic, precious, everything, not so? You see that? Now that will be plus 3 plus 5, not so? Squared. So what is the next step I should conduct what? I should bring this one here, so it is 2. Now look here. Log 5 was given, 2 was given, 3 was. Feed in and add. That one will be what? 0.301 plus 0.4771 plus 2 times 0.6990. But I told you that for a positive term, multiply direct, simply multiply here, give us the answer. But let me say this again, class. When values, listen, when values are positive, no need to add the other stepwise addition that we have. Here you just add by a column. So what do you have on this? What do you have here?
1.398.
398. Add now. We are saying that in case there was any negative, you'd be forced to add like we were adding normally, but for positive terms, don't need to worry. Add with the column. Since you have 4, there are 4 numbers here. Since you have 4, two point what? 761. Yeah. Now let me first receive 2 of you to handle this, and you go and relax. You go and what? Relax. Evaluate. 0.477 squared using. In fact, let's make it cubed using logarithm tables. That's number 1. You pick you pick what you can. Number 2 given log 2 0.3010 and x equal to 4. Find the value of log 10x squared. There you are. So let me have first 2 guys thinking like that's right. You see, yeah, pick on Who is ready? Who is thinking? Just come confidently, never worry. Now we want to put a third one, but come for this first. Which one are you taking over? Which one? You ready?
Maybe number 2.
You come take over any of your preference. Yeah, somebody should first take over this. First take over that. So, first take over. Yeah, now I think we don't have enough enough time. So we request that who is ready? Who is ready to try? People are afraid. Oh, they're afraid. Let's now, this is, since this is that, if you try to bring log on it, it would follow this way as a multiplication. You understand that? So I'll get its log and multi. When you have a reciprocal power, you divide, but when you have just a power, you multi. See? Number, SF, log. So this would be 0.477. 4.77 times 10 power what? Negative 1. What do you get? Six what? 85. Divided by what? Multiplied by? So when we are multiplying, we say the split two parts because it's a negative. So, but if it's a possible, just multiply direct and maintain to 4 decimal. So rough work would say negative 1 plus 0.6785 multiply, you'll have 3 times that plus 3 times that, 785. So what do you have here?
Negative
3 plus who?
2.0.
As if 2 point what?
2.03.
6. No, 4 decimal what? 55. Yeah. Then this is 2, this is 3, this plus that. So negative 1.0355. And log it. See, this is 10 to power negative 1 times 10 to power 0.0355. You get?
I first change it to 3 decimal places.
To 3 decimal? Yes, what is 3 decimals here?
0.036.
Then that would be what? And the whole answer? Now the last, the one number will be here only. So this 0.0036. Okay, now I'm requesting somebody who is doing that, come and do that, we close.
But I'm not sure.
But she's not. But I'm not sure. She's not sure. So,
They've said log
you remove the mask.
equals to 0.3015. And I've told us x equals to 4. So this log 10. And since this x is squared, so I'll square also 4. Let me just say this x squared equals to 4. So for me, I'll do like this. Log 10, 0.30110 squared. Plus log 10, 4 squared.
She would do like that. Okay.
Then I'll shift this to this side. Log 2, 0.31 plus also the toss, I'll bring it this side. One count. Two timers.
It will give you 0.602.
Then here, this 8. Here it will be 10. We shall carry the 1 here. That's what I got.
Yeah, thank you very, very much for being confident and courageous. Oh, now I'm wondering whether we are correct or wrong. You want to try? Yeah, give it a try. As we leave the two solutions there, and you can try from here. That is a Mokisa who? Mokisa Grace.
Okay, so I'm not very sure about my answer.
Say it again.
I'm not very sure about my answer.
Okay.
Given log 10 is equal to 0.30110 and x is equal to 4. Find the value of log x10 squared. So since x is 4, so it will be log 4 squared, and you move this squared to these ends, so it will be 2 log 410. So 2 times 4, it will give us 8. Teacher, I think you can continue from there.
You think I should continue from here? Thank you very much for the stone you've added onto our. So now let us close it this way. Thank you that these numbers were a bit deeper, so they were miscellaneous. So now she started well, but she has not applied this anywhere. But remember that if they say this, then you have to use it somewhere. Now they want you to evaluate this. But what is x? Follow the question. That is 4, not so? See? But the question wants you to use log what? So you'll break this 4 to become what? You can first, this is 4 is 16, not so? That's 16. What is 16 in terms of 2? 4. This one is that. So bring now this. That will be 4 log what? But this has been given. So it will be 4 times 0.310. And that's the answer. Yeah, thank you very, very much for attending this long session. The entire topic was numerical concepts part 1. Part 2 is in 3rd term. And this we dealt with 3 sections: approximation, indices, and what? Logarithms. Now, in approximation, we dealt with rounding off, we dealt with significant figures, and we dealt with scientific notation. So it threw us into indices. We looked at many things, meaning of indices, the laws of indices, solving equations in indices. And from there, it took us right away into logarithm, which has been a very, very long and interesting a journey that has taken us from the laws, using laws, finding logarithms, using tables, finding anti-logarithms. We said logarithms read to 4 decimal places, then antlog to 3 decimal places, but final answers on manipulation must be to 4 decimal places. And we've gone through many other things. Thank you. We meet in the next discussion of topic 5.